Welcome to this lecture on pointers and arrays in C. In this lecture, we will see how arrays act as pointers and how we can use pointers to access elements of the arrays. So let us revise arrays first. We will talk about 1D arrays and pointers in this lecture. So we know that we can declare a 1D array using the data type followed by the array name followed by the size of the array, and if we have to initialize the array in that statement itself, we can specify the elements in curly brackets separated with comma. So this is an integer array example, and in memory the array will look like this. So you have these elements stored. So a of 0 is the first element, that is 5 in this case. A of 1 is the second element, that is 2, and so on. Also, let us assume that each element is stored at some memory location. Now we know that in arrays the elements are stored in consecutive memory locations. Assuming that each memory location can store 1 byte of data, each element of the array, since it's an integer array, occupies 4 bytes in memory. So the next element of this array will be at an interval of 4 bytes each. So if the first element of the array is, say, at location 1000, the next element, the second element, a of 1, will be at location 1004, because the size of an int is 4 bytes. Similarly, a of 2 will be at an interval of 4 bytes, that is at location 1008. So this will keep on continuing for the entire elements of the array. Next, we will see a few expressions which involve arrays using the pointer notation. So the first expression is a, simply the array name a. So in the last slide we saw an array with name a. So when we write an expression a with the array name, so it could be anything. So if your array name is ARR, the expression will be ARR. So in this case the expression is a. This expression, that is the array name written as it is a shorthand notation for address of the first element of the array. So this actually means address of a of 0. So a translates to address of a of 0. Any array, if you write the name of that array, that means, that expression means, it's a shorthand actually of address of the first element of that array. So if this was your array, then address of a of 0 will be 1000 in this case. That means if I write the expression a, if I try to print a, if I write print a inside my printf, if I try to print a, then it will print the address of the first element of this array. So it will print 1000 on screen. Next expression is address of a of 3. So address of a of some ith location. So when I write address of a of I, that translates to address of a plus I. I can use either of the two, they both mean the same. The first, let us see the interpretation of the first expression. So in this array, the interpretation of the first expression is pretty simple. A of 3 is this, and address of a of 3 is nothing but the memory location where it is stored. So the address of operator is just put before this expression a of 3, and you get, instead of the value 6, you get the address of that value, address where that value is stored. So the interpretation of address of a of 3 is nothing but 1012 in this array a. Now let us try to understand the meaning of the expression on the right hand side. how are these two expressions equivalent? How is address of a of 3 equivalent to a plus 3? Let us see that. So let us see the explanation. So when we add an integer to an address, whenever you write some expression where you are adding an integer to an address, the calculations are with respect to memory addresses. So you are no longer just adding 3, but you are adding 3 memory locations to that address. So if so this calculation depends on the type of a. So the type of a is, now what is a? A is nothing but, when I write a, it means nothing but it is address of the first memory location of the array, that is address of a of 0. And what is the type of that? The type of that is an integer address. It is an integer's address. So what does a plus 3 mean? A plus 3 means you are adding 3 more location to that integer's address. Okay, so let us see the expression mathematically. So a plus 3 translates to address of a of 0 plus 3. So you just put your representation, just replace this a with address of 0 and 3 remains as it is. So you get 1000 plus 3. But this 3 is nothing but 3 memory locations of size int. So you have, because a is an array of integers. So what you have to do is you have to multiply 3 with the size of integer. So the size of integer is 4 bytes. So what the address calculation will look like, it will be 1000 plus 3 into 4. So instead of adding just simply the number 3 to 1000, you will add 3 into 4 to 1000. So you have to advance by those many memory locations, how much ever that integer occupies. So each integer occupies 4 bytes. So if you want to advance by 1, so if this expression was a plus 1, then you would just move by 1 location ahead. You will just move 1 location ahead, that is by 4 bytes. So 1000 plus 4, you will add 4 to it. If you write a plus 2, it will be just, it will be 2 locations ahead. So it will be 8 bytes, 4 plus 4. Size of 2 integers you have to move ahead. So similarly, a plus 3 will be a plus 3 locations ahead, 3 integer locations ahead, that is 3 into 4. So it is 1000 plus 3 into 4, which is nothing but 1012. So this expression that we have written, a plus 3, it gives you this value, 1012. So actually if I write this inside a print statement, if I do a printf percent, since it's an address, it will be a %p, printf %p a plus 3, it will print out 1012. So that is how these two expressions are equivalent. So I can always write, instead of address of a plus 3 in square brackets, 3 in square brackets, I can write this expression as well. So I can write this kind of an expression in scanf when I'm scanning an integer array. We will see that later. But for now you understand that these two expressions mean the same. So using the same, just extending the same expression, we have a of 3. When I say a of 3, I know that a of 3 is nothing but the value at the third location of array A, that is nothing but 6. Now this expression is equivalent to star of a plus 3, star of into parenthesis a plus 3. Now let us see how. So first of all, a plus 3 is inside parenthesis, a plus 3 is inside parenthesis. So this expression will be evaluated first following the BODMAS rule. So since this expression will be evaluated first, we already know what the answer to that expression is. So the answer to that expression is nothing but 1012. The answer to that expression is 1012 by the following the previous logic. Now we are simply writing, so that means address of a of 3, 1012 is nothing but address of a of 3. Now we are writing star of 1012 or star of address of a of 3. So star of 1012 is nothing but star of address of a of 3. this star and address of, these are complementary operations, they get cancelled out, and what you remain with is nothing but a of 3, and a of 3 is nothing but 6. So this expression a of 3 can be replaced with star of a plus 3 using the pointer notation. So what we have seen so far is using a pointer notation without using any pointer, but just using the array in terms of pointer notation, you can also write your program. So you have not created any pointer yet, but you are using array as a pointer. So arrays and pointers can be used interchangeably to an extent. So let us see a simple program which will demonstrate this. Okay, so here I have created my array A with these elements 1 to 9, and I have written those 3 expressions for you. First is A. So A is going to print address of the first location of the array. Okay, if I write A plus 4, it will give me address of the 5th location, that is A of 4. It will print address of A of 4. And if I write star A of 4, it should give me 0, 1, 2, 3, 4. It should give me 5 as the answer. So let us run this quickly and see. Compile this and run this. So you see here, you see an address here. This is the address of the first location of the array. Then this is some other address. This is the address of the 5th element of the array, A of 4. And when you say star A of 4, A plus 4, you are expecting 5, and you got 5. So if you have understood what I had explained through my slides, you will understand how this program works. Now this same program, let us extend it further. So what we will do now is, we will introduce our pointer here. So let us say we have an integer pointer. Since each element in the array is of type int, the pointer type which can hold an integer is nothing but an integer pointer to an int. So let us declare an integer pointer. Okay, and let us point the integer to the first element of the array. So by this expression, we are pointing we are making the pointer point to the first element of the array. Why? Because the expression on the right, A, it is nothing but address of A of 0. Now further, if we try to print this pointer P, if we print the value of pointer P, we will get address of A. So we can verify this and this, you will get the same answer. This expression on line number 6 and this expression on line number 11 will give me the same answer. Similarly, if I do a star P, it will give me the value at that address. That means it is going to print A. Here also I can do that. I can simply say printf, just do copy paste here, printf star A. I can write star A. Star A will give me the value at the first location. Because the location is 0, I do not need to write A plus 0, because A plus 0 is A only. I do not need to write something like star of A plus 0, because A plus 0 is A. So I can simply write star of A. I do not need to write star of A plus 0. I simply write star of A. Fine. So this expression is same as this expression. So line number 7 should match line number 13, whatever the output is. So for now, let us run it. So I'll compile it again because I've made changes. Run it. So now I'll see that star A is 1. The first element was 1 in my array, and star P is also 1. Similarly, address of the first element is FEF8, 0061 FEF8. Similarly, P contains address of S, that is why it is also 61 FEF8, 0061 FEF8. So we have verified that. Now let us explore this code further. So now in this code we will see some operations, some arithmetic operations on pointers. So what we will do, we are already pointing this, we have already stored this address of the first element of the array into P. So we are already making the pointer point to some valid address. It's already holding a valid address. So now I can write an expression like P equal to P plus 2. That means I am trying to advance the pointer. I am changing the pointer, I am updating the pointer by 2. I can do that. So P was earlier pointing to this address of this element. Now I am advancing it by 2. So when I write this expression P plus 2, it is the same as that we saw for A plus 4. This is going to increase the address, or it's going to update the address of P by 2 memory locations. It's going to advance the address by 2 memory locations, similar to A plus 2, A plus 3, A plus 4 that we have seen earlier. If I write P is equal to P plus 2, it will advance by 2 memory locations. So initially it was at 2, it was at A of 0, now it will be at A of 2. Right? So to make it easy for you, we have written A plus 4 here. We will write P plus 4 here. So that you can relate. So if I print out P here, it will give me the same value as A plus 4. It will give me the same value as A plus 4. That means that address it will give, address of A of 4. If I print out star P, it will give me the same address as star A plus 4, the same value as star A plus 4, that is nothing but A of 4, because I have advanced the pointer by 4 memory locations. I run it. So star P, okay, this was the last run. So after that run, we are printing the address of the 4th location, which should match this line, FF08, which is matching this line. Similarly, the value at that location is 5, which we have printed out here. So this is matching this. So what we have done is, instead of using the array as a pointer, we are making a pointer point to that location. We are just advancing the pointer by those many locations, and it does the same job. So now via the pointer also you can do the same thing, which you can do via the array only. So both ways you have seen, using just the array using pointer notation, and now making a pointer point to that array and performing pointer arithmetic. You have performed some arithmetic operation on the pointer. There are some more here. I'll just change this to the original one. I can also write an expression like this. So I have written an expression here. What I have done is I have simply written P plus 3. So whatever the current value of P is, the current value of P here is P of 2. It is containing the address of P of 2, A of 2. So 0, 1, 2. So it's containing the address of A of 2. P is currently containing the address of A of 2. So when I write this kind of an expression, P plus 3, it will be A of 2 plus 3 memory locations, that is A of 5. So this will be address of A of 5. So this should print address of A of 5. So if we just and to just validate this, what we can do is, we can check the star value at that. We can check the value at that location. So this should print me A of 5. Let us check the A of 5 value here. A of 5 value is 0, 1, 2, 3, 4, 5. It is 6. So it should print 6. This expression should print 6. Let us see. So rightly that expression is printing 6, and this is the address of that location, memory location. address of A of 6. Also address of A of 5, the 6th memory location, that is address of A of 5, one less. Okay, further we can perform any kind of arithmetic operations on pointers which involve addition or subtraction. We cannot perform any operation involving multiplication or division. So addition and subtraction is perfectly valid operation for pointers, because pointer stores addresses and you can perform addition and subtraction of memory locations. So you can do a p plus equal to 3, it's valid. So initially, instead of using this simple plus, I have used a compound assignment operator, which is perfectly valid. You can do a p minus minus, you can go back, you can advance the pointer ahead, or you can go back in the reverse direction, you can do that. So at this point, what is the value of p? P was pointing at A of 5. P will now contain plus 3 locations, so it will be A of 8. Do I have those many numbers? Yes, I have. So it is pointing to A of address of 8. If I try to print it after this, I'll be able to, if I do a star p after this, I will get the last element, that is 9. So let me put that here. So after this, if I put star p, I'll get 9. I should get 9 as the output. Then I can do reverse, I can decrement it, so I can go back. So I will get address of A of 7. So address of A of 7 will be the current value of the pointer. So if I print it out, I will get address of A of 7 and the value will be 8. So let me comment this out for now. Let us run it again. So what we have done is p is equal to p plus 2. Okay, so I made a mistake here. P is equal to p plus 2 I have done, but I have not changed the pointer yet. I have not changed it to 3. So this should be A of 5. This should be address of A of 5, because I have not changed it actually. I have just printed out p plus 3. I have not done p equal to p plus 3. I have just printed out the value of the address of p plus 3, the value of p plus 3 rather. So I have not modified p in any way. The modification that I have done is only here so far. Here I have not done any modification to the pointer. I am just printing an expression involving the pointer. Modification means I do not have an assignment operator which reassigns it to some new value, right? I am just printing it out. So this should be A plus 5. This should be address of A of 5, because after this is nothing but address of A of 2. Let me write it. So again I do a plus 3 to A of 2, so it will be address of A of 5. Then address of A of 5 is the 6th element, which is 6. So this should print 6. Star p should print 6. P minus minus will be address of A of 4, because now you are at location 5, so it should be address of A of 4. Similarly, so if I print this, it will be address of A of 4. And star p should be the value at A of 4, that is nothing but 4. 5, sorry, it will be 5. So 5 should be printed. So let us go back to the output and check. So 5 was printed, the address was printed, previous value was 6. So 6 was printed correctly here. So everywhere we have printed. So 6 you have printed here. Before that also 6 is printed, because A of 5 was printed. So that is why there is a 6 here as well. Some more expressions, last few expressions for this video. So we have seen how to access the elements of an array using pointer notation involving the array itself, and also using a separate pointer which points to that array. So starting with the first address, you can keep on moving the pointer up or down the array. So we have seen that. You can also write this kind of an expression where what you're doing is you're dereferencing the array first and then you are adding something to it. That means, let me break down this expression for you. When I write star of p, I have not put any bracket. Remember, in this expression I have not put any bracket. I have simply written star of p. What does that mean? It simply means that p will first be replaced with wherever it is pointing to. So my current p value was pointing at address a of 4. So I will just write, instead of p, I will just replace it with address of a of 4. The last one, the last update was this. I will just replace it with that, and star is still there. So this expression now becomes star of address of a of 4 plus 2. Star of address of a of 4 plus 2. So star and address of our complementary operators, they get cancelled out. So we get only a of 4. What remains? Only a of 4. Now a of 4 is some value plus 2. What is a of 4's value? It is 5. A of 4 is nothing but 5. Add 2 to it. So answer will be 7. Similarly, you can guess what this expression means. The answer should be a of 4 minus 2. That is 3. The answer should be 3 here. And the answer should be 7 here. Fine. Let us verify that. So answer is 7, answer is 3. But why this 7 in this manner? Because I made a mistake. I put a %p here. I should put a %d. So it's using the hexadecimal notation there. So now it's correctly printing 7 and 3. So hope you have understood how how arrays act as pointers, and also how you can make an array pointer point to a 1D array. And we have also seen some expressions and some arithmetic operations involving pointers in this video. Apart from this, I just want to point out one more thing. Arrays are constant pointers. That means you cannot perform an update operation on arrays. You cannot write a equal to a plus 2. This is invalid syntax. This is invalid for an array, because array is a constant pointer. You cannot keep on changing the memory address of arrays. Once it is initialized, once it is allocated by the compiler, you cannot change it. They are constant pointers. A plus plus, a minus minus, these are invalid expressions for arrays. However, they are valid for normal pointers like int star p. P is a normal pointer to type int. So p plus plus, p minus minus, all these are valid for p, but they are invalid for a. You can write the expression a plus 2. You can print it out, but you cannot reassign it. You cannot say a equal to a plus 2. I hope you have understood these concepts. I will just pass over this program to you as well, so that you can run it for yourself and see along with the video. Thanks for watching this video. I'll also send a few examples for practice, so that you get a hang of arrays and pointers, especially only 1D arrays. So thanks for watching, and bye bye.